Hello, everyone. I see everyone's populating in so far. Welcome to part 2 of the Pico Scope PS7 advanced settings. We're going to touch on various subject matters that is a continuation from part 1, but we're going to get a little deeper and be able to take in a lot more questions more related to the advanced settings and some tech tips related to some of the advanced settings that is within the realm of engine management sensors and also just the basic communications on the vehicles in which you can make best use of utilizing the Pico scope and the PS7 software. So we have Randy Dillman with us, and I'm Philip Austin. Welcome all. We are going to kick off with some polls, of course, in order for us to understand basically who's in the room and what your feelings are about, the next webinar as well and the timing. Okay, so at this time, please, as others are entering in, we have a poll out for you to participate in. And we're assuming everyone understands the different levels of Service Tech A, Service Tech B, or Service Tech C student. Great. All right, nice. We're gonna give this 2 more seconds and we'll close it out. Great. Now, Randy, this is what we're looking at. Hopefully everyone can see the poll results this time. We have 19% educator / instructor, 54% Service Tech A, 3% Service Tech B, 1% Service Tech C or student, 22% other. Okay, great. And let's and 73% of us actually participated, so I'll take that. All right, now we're going to close that out at this time and be able to move on. All right, so the next poll is more about the timing. We always want to be sensitive to everyone's time, even though this is going to be recorded. So again, we're going to have a part 3 because we've gotten so many questions and some additional points that the audience members from part 1 wanted to ask. We could not take care of all of that in the part 2, so it gave birth to a part 3. So again, we're going to ask you the same questions. Is this lunchtime on the East Coast okay with everyone, along with how it has went in the past? And also keep in mind, there will be a recording as well. And please understand, we can't always have a time period that's going to work with everyone, but we feel that polling is the best way, and it would go off of the largest percentage of. All right, great. So we got 54% is still cool with the lunchtime of the East Coast time, and 13% would rather evenings, and 34% they're okay with either, because you understand you could go and watch the recording afterward. Okay, great. So at this point, I'm going to turn this over to Randy, and we could get rolling here. And thank you all for participating in the polls. Here you go, Randy.
Okay, thank you, sir. Let me show my screen here and get this thing rolling here. There we go. Okay, great. Thanks for joining everyone today. Again, as Philip said, this is part 2. I always ask, certainly watch part 1 if you've not done that so far. Part 2 is just, I'm gonna just start really where I left off in part 1 for part 2, and then we do plan on probably doing something in July, part 3, just because I know I'm not gonna be able to get to everything that we've discussed between those that have already attended and Philip and I. So today then, since we've already been through the top toolbar of PS7, I do want to head down the vertical side. I want to run down the left-hand side. Channel options, I really want to talk about filtering, and I want to get our startup settings done, and then I do want to do some cam and crank here by the end of this event. So I'm using stable today. I am going to pop into early access as well, but I'm going to start here with stable and start right over here. I'm in demo mode, so I do have a scope plugged in, but I'm in demo mode for right now because that's really going to help lead me into my startup settings. And we have to discuss demo mode versus a live communication mode when it's connected to the scope. We have to talk about both because the user interface actually does change between those two, and I think that's a kind of a key thing. If you're only using it in demo, maybe you don't even own a scope yet and you're just looking at demo mode, there are options that don't populate until the scope is actually plugged in, and that's kind of where I want to start at today. So I'm going to go ahead and open up one of my channels here. In this case here, I'm just going to pick the channel A lozenge button here. Maybe in the US, lozenge is what we internally call it. Again, it could be 2 if you have a 2-channel, 4 channel, which is what I have plugged in, or if you've got 8, it populates 8. I'm going to click here right in the center of the menu and look at this. When the flyout menu for all the flyout menus for each channel are the same, so I can pick any one of these and cover my pull down menus as well. Now you've got 4 pull down menus in each one. It does launch in the vertical. So I've got my vertical scaling here, no big deal. I've got coupling mode and invert. Now, I really wanted to start here because in demo mode, that's actually all you get. When I plug a scope in, I'm going to have several more options, one of which is filtering, and I think it's pretty important to note that when we add filtering here, we've got Pico Scope 7 has 2 different filters. So if you're taking any sort of notes, or even if you're just taking mental notes, we have 2 filters. We have a hardware filter and we have a software filter. So if you're in demo mode, you're only going to see one, which is our software filter. So I'll start with that here relatively quick. So for vertical control here, we've got probes in our second pull down, BNC plus options. BNC plus accessories aren't really in the list because they will self ID when you plug them in. Everything that we've got in the list, a visual list now, not a written list, but a visual list. These are all BNC accessories. And then next over is DSP. Now, do you get questions about this? I get questions about where's the filters at or where's the low pass filter at. DSP is low pass filter. DSP, digital signal processing, is actually an industry term. It's a test and measurement industry term. It's really been part of our test and measurement and really most scope usage almost since the beginning. So we went ahead and added that acronym into the automotive world. As I said before, going from our older software to PS7, we really tried to remove acronyms. This one was added. It wasn't anything we made up. DSP's been DSP, digital signal processing, for many years, and it's kind of the standard. So when we talk about filters, and I've already mentioned 2 filters, this is our software filter and this is our low pass filter. So you can turn it on and off here to make it active, and then you can change the frequency however that works for you. Now, just a couple notes about filtering. Filtering is not for the scope. So the scope doesn't care about filtering. It doesn't care how you filter it. The trigger is still going to trigger off of the raw data or the unfiltered signal. So filtering is strictly just for us, the user. It's for our eyes. It's for maybe we're trying to analyze and we're trying to pick out what's important and what's not. Sometimes we're in a very noisy environment, or the leads are run across something that's very noisy and we have to remove that. again, it's not really necessarily for the scope. It's really for us. And so when we talk about two filters, software filter is DSP. What I mean by software filter is it's all strictly done through the software, no real hardware involved, and I call it a forgiving filter. Regardless of how you use the filter, whether you save the file filtered, you can always open the file or send the file to someone. They can open the file and they can turn the filter off. I think it's recommended for the most part, you always start with a non-filtered signal. So you can save it with or without the filter for DSP. It really doesn't make any difference. So I'm going to end on this particular section here in the display. You can change and you can put the titles. If you wanted to put CKP here, that will show up where your channel A lozenge upper left-hand corner is. You can change the colors. You can also change the scaling and the offset. That's where that's actually located at. But for this particular case, I really want to come back here because I think this is really important. We've got a software filter, which is very forgiving. You can add and subtract that even off of a saved file. But we do have hardware filters, and you won't see that until a scope is actually plugged in. So I'm going to go ahead and connect a device. So let me connect my scope. It's going to close my channel menu, and I'm going to reopen that channel menu. I'll stop the scope. And I'm going to reopen that channel menu, and now you're going to notice that we've got bandwidth limit. We've added 0 channel offsets and frequency counting. And this is because I've got a scope plugged in. Now the bandwidth limit is this hardware filter that I'm talking about. Just think of a hardware filter as something that you're going to plug into the input channel, the BNC channel A of the scope, and then you're going to plug your lead on top of that. That's what I want you to visualize as far as hardware filters go. It's not something that's very forgiving. If you save the PS data file, you save the signal, you save the buffer, and it's got bandwidth limit turned on, which is pretty easy. When you turn it on, you'll notice here up in my channel A button or the lozenge, it shows filtered now. When you turn that on, and if you save that file, the file is permanently saved with that hardware filter installed. When you open that later on or send it to someone and they open it, the button, bandwidth limit, if they've got a scope plugged in, the bandwidth limit is going to be live. You can turn it on and off, but it's not going to change the pattern. So it's only going to change the pattern when you start the scope again. So it's not very forgiving. So there's a couple of things I mentioned for that. You really don't want to heavily filter something and then save it with bandwidth limit, even though bandwidth limit cuts it at 20K and it's not adjustable. It's a 20K bandwidth limit. We use that bandwidth limit for all of our probes, our current probes. So not our ×1 test leads, but our current probe. So let me demonstrate that. I'm going to go ahead and turn that off. I'm going to restart my scope. You also notice too that when I initially launched, I had some of my demo scope settings that were still in my channel. I didn't point that out, but that were there. We're going to fix that as well, because starting a scope in default mode or factory mode is probably not what you want, because everybody will probably start a scope different, and we're going to set that up as well. But we're going to set that up only when a scope is attached. So in this case here, I'm going to go ahead and take a high amp clamp, our TA388, and I'm going to plug it into channel A. And it's going to self ID when I plug it in. And when it does, it'll tell me it's DC coupled. We're 2000 amp, it's got the 2000 amp clamp plugged in, and it shows filtered. So my bandwidth limit will automatically turn on when I plug that in. I am able to turn it off, and I can unfilter that and turn it back on again. But when you plug it in, if you don't change the bandwidth limit, it will always be turned on. We have found that with our current clamps, that's really the best way to use them. They can get pretty messy with the bandwidth limit turned off on our current clamp. May not do that on a ×1 test lead, but I would certainly do that with a current clamp. But we give you the option to turn it off, and that way you can do so. And you'll notice that by just looking at the channel without even opening the menu, you'll notice that it's filtered or not. So again, this is a hardware filter. It's not software filter. When you save it and you reopen it, that signal is going to be filtered, and you can't unfilter it. So you can't undo that. So 2 different levels of filtering. So I always make sure that I get PS data files every week, every day almost, and if they've got the bandwidth limit turned on, maybe if I wanted it off, there's nothing I can do about it. With DSP, I can turn it off. I can go look at the raw data. So not really a problem there. So hopefully that helps with the other options. Now I will go back here, and just as a quick note for coupling, just to make sure everybody's good, AC couple is only going to show the AC, DC is going to show both. So yes, the channels always default to DC, so you have both. Typically your channels will default to the auto range mode, which I get emails and I get phone calls about. You can go in and do your startup settings, put them to manual mode. The one issue that I see is in auto mode, if that signal is in between 5 and 10 volts, or maybe it really is 5 volts, but it's got something riding on top of it, it may switch between 5 and 10 volts, and it'll do that, and you're not doing it, and it makes the signal look erratic, or it's not stabilized or something. It doesn't look good, and that's the auto range mode that's currently set on, and that again is by default. You can go in and do your startup settings and put them to manual, and they will stay manual when you do your startup settings. So I will certainly run through the startup settings when we get there. Okay, so that takes us through our vertical. It takes us through our probes, takes us through filtering, it takes us through display, so we can change any of those options when we want to. And we talked a little bit about filtering. Now for startup settings to be handled, again, it's with a scope attached. You can set your startup settings in demo mode, but I think I mentioned in part 1, they're really handled differently. Demo mode with no scope attached has kind of its own setups, and then a regular live mode with the scope attached has different setups. So I always suggest, most of us really don't care about demo mode. We're only using it to learn the software anyway. So I normally suggest that you use the scope attached. And then for startup settings for me, just as a quick example, I can come over here to my customizable menu, and we're going to talk about the customizable menu because we've really got 2 menus going on here. But I can go into the reset configuration button. So if you want that button that basically resets it back to your startup settings, that's what reset configuration does. Now I'm going to go ahead and click on this. It will give me the option to, it's going to tell me it's going to apply the default scope settings. I'm going to go ahead and do that. And I'll let it reset itself. And these are my startup settings. It's going to tell me, are you sure this is what you want to run with? Because typically I don't have a current probe attached. I'm going to say yes. I'm going to go ahead and run with that. In fact, I'm going to go ahead and just remove my current clamp here and look up a time zone test lead here. Okay, I'm going to go ahead and hit my reset again because I had a current clamp attached. Let the scope reset. And again, it's going to be a kind of a personal preference type of thing. Everybody's going to start up their scope different. So in my case here, I start with my channels A and B on at 20 volts, 0 plus or minus 20 volts. I keep C and D off. I have it set at 20 milliseconds. We briefly discussed this in part 1, and we will expand this in part 3. I'm using fixed sample rate mode. I like to use 1 million samples. That actually makes it custom. If you use normal, that's 2 million samples. That's fine. I know it's not a lot of difference, but it does make the file size larger as you go to the larger sample rate. I've always used 1 million. And I think I told you before, we voted on 1 versus 2. I was in the minority and lost, and so it went to 2 million. But a lot of times I will use 1 million for that. But I'm still in fixed sample rate mode. I have no trigger set. We talked about trigger before. I always prefer to start the scope with no trigger. And I also like to make sure that I've got well-defined zeros and that they're not set something like this, which I find can be confusing, especially when they have a signal running on top of them. So I like to make sure that they're well-defined, and I don't prefer that they're on top of each other. That's just me. Again, everybody starts a scope different. I do always recommend, though, if you're not going to use all 4 channels, don't turn them on. Keep the channels off when you're not using them, because it obviously reduces your your sample rate and the memory for the scope. The more you have open and turned on, the scope doesn't know whether it's hooked to anything or not. So only have the ones open that you're using. So in this case here, 20 and 20, no trigger, 20 milliseconds. I've got my well-defined zeros. I'm pretty good. Now, so step one in your startup settings is just get the scope the way you want it. So every time I hit the reset configuration button or I start the scope, and remember, starting the scope to use is the scope is plugged in first and then the application is launched. You can skip a whole step if you don't do it the other way around. So plug in, launch. This is how that scope is going to start every time. So again, it's a personal preference thing. Maybe you only want to have one channel open. Maybe you really do want all 4 channels open and then you'll close the ones you're not using. That's fine. Maybe you like a long time base. I'm using 20 milliseconds. Maybe you want to be in streaming mode and you're running 2 seconds or 5 seconds per division. That's fine. You set it up the way you want to set it up. But the next 2 steps, they do have to be in this order. So the first thing I'm going to do is I have to go find the settings in my menu. So again, I got 2 different menus going on. I'm using the current stable, 7.1.21. If I open my more menu, my more flyout menu, this is our, I guess what I'm going to call the old more menu. It's currently still in the stable, which means it's currently still the one we are using in stable. And I need to find the settings, which is the icon of the gear. I'm going to click on that. And at the very top, it says startup settings, factory user last session. If you've never touched it, it's going to be set to factory, which means you're going to be using what we set the scope up with, probably not what you're going to want to do. So make sure you click and change that from factory to user. And then you can close that screen. You can just close it by clicking on the graticule anywhere and it will close the screen. Now you'll notice that off my more menu, this is what we've been running for 4 years on the more menu from top to bottom. I'm using the scroll on my mouse. It's top to bottom, not really what you'd call organized. Now, if I open up my current early access, which is 7.1.29, and I open up my more menu, you're going to notice that the configuration or the organization is all different. And we have organized it now. We're pretty set on everything that's in here and we've got it organized and we've got labels on the organization. So in most cases, when you're analyzing the waveform, you're going to be under waveform evaluations, which is where your math channels and your actions, masks, and measurements and stuff are. In my case here, I was going to go after settings. So it's under setup and configuration. Just something that we did with really feedback, a lot of feedback that said that list is kind of random, not even in alphabetical order. Can we not organize that? Can we organize it more? And this is how we're organizing it. And I'm really showing this because this is in an early access. Am I 100% positive that's going to be the final for the next stable? Because remember how this works. Early access is built on the current stable. So 7.1.29 is 8 or 9 updates ahead of our current 7.1.21 stable. We'll increment that, and when it goes to 7.1.30, maybe that's going to be our next candidate for stable. We'll bring stable up to 7.1.30, and then we'll move on, march forward with early access. But that doesn't mean that every change we made in all of those updates makes it to the final stable. So I'm showing both just because, I don't really know. I don't really know if it's going to stay that way or not. So I'm assuming this and the save menu will stay the same, and we're not going to change that. But again, I don't know, and I have a lot of people that won't use early access anyways. They're only going to use stable. So I'm showing both for the video. It'll be a mute point. I'm sure in a few months it will get settled out how we're going to do that. I'm going to go back to my stable because that's what I'm using and that's what I've got my scope attached to. So first step, set the scope up. Second step, go telescope. I don't want to use Pico factory default settings. The last step then is to go to your save menu, which is the icon of the floppy drive, which is still kind of funny to me. And I need to go over to my file type, which is right above the waveform selection. And I need to set or click on, highlight the user default PS7 PS settings. So the steps are, the scope is ready to, the software is ready to accept what we want as our startup settings. When we push that reset button or when we launch the software with the scope attached, this is how we do it. Step 1, set the scope up. 2, tell the scope I want to use user defined. 3, go to the save menu, click on user default settings and come down here to the save button, click the save button, and you're set and ready to go. So every time that I launch this or I hit the reset configuration button, I'm going to get, in my case, 0 plus or minus 20 volts, no trigger, 20 milliseconds, my fixed sample rate, and my zeros where they're at. And again, it's all personal preference, however you're going to want to do that. But I think that's pretty important to make sure that you're not aggravated because every time it launches in a default setting, and maybe that's not what you want at all. And that was one of our questions that we received about startup settings and getting our startup settings the way we want them. And now we've looked at both of the more menus and more flyout menus. I do believe that it's going to be that more organized early access. I think you will see that in the next table, which will probably be out in the next month or so, maybe even sooner. So my getting into something that's a little more advanced here, I'm going to go ahead and give us a signal to look at here. And I'm actually using a waveform simulator. And I'm going to just set this to on and keep it on here. Okay, start my scope again. And again, I've got my settings the way I want it. And I'm actually looking at an actual cam and crank sensor. So we want to talk about cam and cranks and maybe really advanced trigger. So we talked about trigger last month. In fact, let's just kind of review that really fast. I'm going to increase my time base a little bit here. In fact, just to make things simpler, I'm going to go in and turn B off. So it's not moving around. And now we're just looking at A. Again, so I'm only using A and B. C and D are off. I have nothing hooked to C and D on the scope. So the channel, the A channel here is hooked to my sensor simulator. It's actually on the crank sensor. B, the red one, was actually on the cam sensor. In order to stabilize this, and we talked about our simple triggers, our edge triggers last month, we had to select which mode we wanted. We talked about the modes. We talked about you had to select the source, and then you can change the pre-trigger, the amount of time or divisions off the left-hand side of the screen, and the threshold, which is the vertical up and down. And also the direction. Is it going up? Am I triggering on a rising or a positive slope, or am I going down? So I'm going to go ahead and set my auto. And again, auto forces a trigger regardless of a valid trigger point. So if I'm up here, we remember what happens here. We don't have a valid trigger point, and it's going to fill a buffer and just throw something up. But at least you know you've got a signal coming in on channel A. So I need to lower that back down. And you'll notice that when I do, it doesn't really make any difference. Besides, I've got live data out of my buffer. The pattern itself isn't synced or isn't triggered because this is a simple edge trigger. Just we've got the picture of it. It's a simple edge trigger. We're only triggering on the vertical voltage going from low to high. In this case, low to high at 1.2 volts. I'm 44% off. Let's just make that even. I'm 40% off, or 4 divisions from the left-hand side. And that's all I'm triggering from right now. Not going to stabilize it because the actual pattern is going above and below that point. We, our eyes, want it to trigger on the missing tooth, but the scope, it doesn't care about a missing tooth. It's only looking at the actual voltage, which it's meeting that threshold every time it updates. It sees that rising voltage at 1.2 volts. It crosses that line. It draws the trace. It's not doing what we want it to do, but it's doing its thing because we're just using a simple edge trigger. So what I want to do is I want to work on setting the time base up. The last thing we want to do on any of these type of sensors, cam and crank, is we don't want to replace parts the car doesn't need. And so looking just at a basic signal and not understanding maybe the encoding, that's encoding, not understanding the encoding of it is important. And we need to know the encoding of the cam and the crank, especially when we're diagnosing an actual cam and crank fault, or are we doing cam and crank we comparing the cam and crank correlation to find out if there's a timing issue or not. So I want to sync or I want to trigger channel A. We're going to do that by our advanced triggers. So I'm going to leave it in auto. I'm going to leave it on channel the source A. I'll leave all the rest of this alone, but I have to go in here and I have to change our type. So we've got a lot of types, a lot of stuff for you to explore. I personally use the pulse width a lot. You can look over all of them, but for me, I think the pulse width works really good for a lot of my time-based triggers. So I'm going to go ahead and select it. It will change the picture to pulse rate, pulse width, and then it gives us some options that we need. So the first thing I need to do, I always stop the scope. I'm going to zoom in here. So I'm using my magnifier upper right-hand corner. And I'm going to zoom in a little bit here. And I need to make some measurements. Now, if we want to trigger on the missing tooth, which in this case where the signal goes from high to low and it stays low for a much prolonged amount of time versus all the rest of the switches, then I need to bring in my rulers, and believe it or not, I'm not measuring the missing tooth. I need to measure a regular tooth. So I'm going to bring my measurement tool over here, and this is just rough measurements. This doesn't have to be exact. And I'm measuring the low point, the low position on a regular tooth, and it's roughly right up here where it says delta. So this is measurement ruler 1, ruler 2, and then the difference between is roughly 134 microseconds. So I always start with what I'm actually not a trigger on. This is just how I do it. You may do it different, but I need to measure what a normal signal looks like, or a normal trigger or normal tooth looks like, and then I'll slide these over. Now I'm just going to lock the rulers. I'm going to go up here to the lock key, and I'm going to lock it, and I'm going to bring both of these over here real fast. Because I'm at 134, I'm just going to make a mental note of that, but that's microseconds. I'm going to unlock them here, and I'm going to move my right over, and this is going to be a lot bigger than that. Just to be safe, I'm at 550 microseconds, so I'm going from 134 to 550, actually a little bit more than that, because I need to know when I'm setting up time base, I need to know what I don't want to trigger on and what I do want to trigger on. Okay, so I'm going to go ahead and open up my trigger function again. Pulse direction here is, do I want this? Do I want to trigger when the signal is high? In this case here, no. I want to trigger it actually when the signal is low or negative. Do I want to do greater than or less than or inside or outside the range? I think in this case here, I'm going to select greater than. I want to be greater than the good tooth that I measured, which was 135 or so microseconds. So I'm going to go to time 1 and open up that box. We get a calculator, and I'm just going to put 200 just to keep it simple, and make sure you select the correct time base itself, which is microseconds, not milliseconds, but microseconds. Okay, I can close that. And let's go ahead and start our scope and see how we did. I'm going to go ahead and close everything out so we can take a look at it from a little bit of a wider distance. And you can see I've synced my crank. Now what I always do, and this is just me, you do it the way you feel comfortable, but I always try to break my trigger just to make sure that I've not, I don't know, gotten lucky and I've got it to work. I want to make sure that you know, we've got this working well, I suppose. I'm not inside that range anymore. I'm not inside the window that I initially set it up at. I can lower it back down, and I can make sure that it's synced properly. Okay, so that's one way to do time-based trigger. And again, we have a lot of different options. So I always suggest that you spend a few minutes and go through those.
Hey, Randy, we're losing your audio a little bit. And hey, Randy, your mic cut out.
Actually not. I've got a terrible storm coming through, unfortunately, in Indiana, and we're just getting pounded. So I noticed that it clicked off, so I stopped talking. So I'm gonna resume where I was. I don't really know where it cut out at. So I think I'll just back up a little bit if that's okay.
Mm-hmm.
Okay. So let me go back to where I was. I had just channel A. I just had my crank, and I had went ahead and set my trigger up. I did that, of course, by measuring a good tooth versus the wide one that my eyes wanted to trigger on. That's where I wanted to stabilize this point at. So I knew I was at 135 milliseconds or so, and I knew that this wide was 550 or so. So when I set my trigger up, I went ahead and trigger when it was low, and I was going to use the greater than time condition, and I set my time at 400 microseconds. That put me above the good, but below how wide it could get. And I always, as I said before, I always like to break, or maybe I said it and you didn't hear it, I like to break my triggers. So if it's triggered properly, I want to make sure I just didn't get lucky. And so I'll go back in here to my time, and I'll raise this so I know it's going to be above the window that I measured, and you'll quickly notice that now we're back, we're all over the place again. We're not properly synced or properly triggered because I've broken it again. So I'm going to go ahead and lower it back down where it triggers. So I've got my crank triggered properly, and I'm not doing an edge trigger because that's not going to work. I did a time-based trigger, which is work because I'm really after this missing tooth. And I'm going to go ahead and turn on my channel B. And again, I'm watching the screen now, make sure everything looks good. And you'll notice that while my crank is triggered, my cam is not. My cam is not synced, or it's not triggered properly. Now, I know some of you are already probably yelling at your monitors, full well knowing that if you're going to do cam and crank correlation, you're not going to trigger on crank. You're not going to use a crank signal to trigger for cam and crank. We all know the cam, the crank is 360 and the cam is 720. So one revolution of the crank is going to get you don't know which the orientation is on for cam encoding. So you're almost always going to trigger off of your cam encoding, especially if it's an encoded signal. You're always going to want to start on the cam, not the crank. I just did it because my crank happened to be on channel A. So in order to trigger this cam crank properly and to look at the encoding and to make sure, do we have a signal issue, a signal integrity issue? Do we have a sensor issue? Or do we have an encoding issue? Possibly the wrong reluctor, the wrong crank, the wrong cam, the wrong engine. I'm sure you've seen them before. I've certainly seen it before doing mobile for 13 years. They put the wrong engine in it. They put the wrong head on it, the wrong cam. They can put the wrong crank in it. So it's not about the sensor just switching. It is about not only the correct encoding, but it's the correct correlation. So that all has to be monitored. So to do that, I need to switch my trigger to channel B. So I'm going to do that here.
And also,
Okay.
while you're doing that, Randy, just as we're getting some questions and comments in, also too, some have created the best practice of triggering off of the ignition primary one. and being able to, or even having a low amp current probe as well on
You could
this.
do that. Yes, you can certainly do that as well. I don't have that in the simulator, so that's why I'm using cam and crank, to be perfectly honest with you. But yes, using a COP on number one coil pack or using a current clamp on the number one coil, not all the coils, not putting a low amp probe, a low amp clamp across, looking at, you don't want to look at all 4, 6, or 8 ignition events. You'd want to just use one. So yes, going to coil pack is great. Typically I use COP. I'm going to use it even if it's not COP, and I'm typically going to use it on channel D because that's not a color that I see very well. So I will put it on channel D, move it out of my way, and then I can analyze my cam and crank. But that doesn't improve your skill of using time-based triggers. Even using ignition, the trigger can get not very settled because ignition does bounce around a lot. So it's fine to use COP. It's fine to use a secondary source that you're not analyzing, but I don't think that improves using a time-based trigger, which is what really kind of the focus here is to just add another tool to the toolbox when we're using it. And I think PS7 does really easy job. You can look at pictures and you can kind of read greater than, less than, inside, outside, positive and negative. You can kind of go through it pretty fast. Clearly, I'm going to have to adjust my trigger at this point in order to sync off of cam, off of A and B here. So off of B, so I can sync A. So I'm going to go ahead and stop, and let's just look at B for a second. Okay, it looks like I've got a narrow, got a medium, and I've got a wide, and so that's going to be my 7. That's going to be my 720 in between two of these missing teeth here for my crank. So I can do something like this, just really quick, and everything in between these on channel B is going to be my it's going to be 720 for my cam. So in order to do that, I've got to I just walk it through my mind verbally is all I ever do. So what do I want to sync on? My eyes, I'm going to want to sync on probably something going high here. So maybe I want to sync on the wide tooth here. Maybe I'd want to sync on the narrow. Maybe I should just do them both for practice anyway. So let's look at the wide. In order to sync on the wide, I'm not going to measure the wide. If you followed the last time, I'm going to measure something I'm probably not going to sync off of or trigger off of. So in this case here, let's just go down to the medium. And again, these are just rough calculations here. They don't have to be perfect. And it's about 5.5 milliseconds. I can lock them again and move it over to here. This is clearly going to be a lot bigger than 5.5 milliseconds. In fact, let's just make a measurement here real fast. And it is a little over 7 mils. So again, back to my trigger point, back to pulse width. I'm going to make sure you select your source. Moving the trigger point down doesn't mean anything to the scope. You've got to make sure you select the correct source. In this case here, I don't want to be on the negative. I want to be on the positive. I want to be where the signal is high, and I want to be greater than the medium one that we had here, which we had over here, which was roughly around, I think if I probably guessed it around 5 or so, I'm going to be okay. Maybe I'm going to have to go to 6, something we can work with. Okay, so back here, I am positive, I'm greater than, I have to change this. I was at microseconds on the crank, so I'm going to have to go to milliseconds here. Let's go to 6 milliseconds and see how we do. Turn scope back on. And so now I've using the measurement that I made on the medium width tooth, I've now synced on the wide tooth because I know that I have to be greater than this, and I can probably break that pretty fast. I can probably go in and go to 5 or maybe 4 and probably break that pretty fast, just proving that I synced it properly, and it wasn't just because, you know, I was pushing buttons and I wasn't quite making my measurements or wasn't measuring them at all. Maybe I was just eyeballing it, which again, I don't find that's easily obtainable or at least repeatable. So even setting it at 5 milliseconds, it's bouncing around. So I'm going to have to be I'm going to have to be over that. I'm going to have to be much wider than the medium width tooth in order to trigger on the wide tooth. So again, I mean, you're not just going to use this for cam and crank. You can use this for anything. I find it, especially ignition, when ignition is bouncing around all the time, especially when the engine is running, it's bouncing around all the time. Triggering on the vertical, triggering on simple edge, the scope doesn't always trigger well. It will bounce around. We call it jitter. So if the scope is jittering a lot, maybe moving to a time-based trigger and not a simple edge is going to help. We've even got an advanced simple edge with hysteresis, and it still doesn't always work really well for ignition. So I like to use the time-based trigger for that. If I want to flip around and go to the narrow one, I already know what the wide one is, right? We already measured the wide one. In fact, I can lock it in and bring it back over here. We know that, again, to trigger off of the narrow, I have to have one I don't want to trigger off of that's next to it, which in this case is 5.5. So I can probably say anything much less than that is going to work. So I'm going to do less than, and I'm going to go in here and I can change this either by the numbers, or I can just use the plus and the minus on each side of the button in order to make it work. In this case here, I'm below 5. We know the medium one is really above 5. It's about 5.2 or 5.3. So anything less is going to be good. Again, I can break that. I can probably take that back down to where it's more narrow than it should be, and I can break the trigger point. So again, it's just something I've always done. Maybe not simple edge triggers, of course, but when I'm using my advanced pulse width triggers, I just make sure that have I measured this properly. I just don't want to get lucky and randomly push buttons until the thing settles down, as some will do. You can measure it and make a proper selection here and stabilize the pattern faster than you can push buttons and get lucky. That's what I've always found. So if I can take one measurement, in this case I took 2 because I did the wide one, and then we wanted to do the narrow one, and then you can do in between if you wanted to do the medium. So again, I find it's a lot of my advanced scope users will using some creativity, you can do a lot of the things, and you can do it. You may do it way different than what I've just done it, but I think it's a useful tool to have, and it's also really useful, when you're just looking at cam and crank, not just to evaluate correlation, just making sure that the sensors are working properly. Last thing you want to do is put a sensor on that the vehicle didn't need, especially when you're just looking at a switch from low to high with a voltmeter, or you're just looking at an average or something like that. That's, you really got to take a couple of steps further. And I think cam and crank at the same time, triggering them properly, whether you're using, a COP or ignition on number 1, or whether you're using something like this, any of those options work. I always suggest, though, working with something you've not done before. You're not really going to get any better using a scope. You really do have to practice it. It's just like any learned skill, playing an instrument or athletics. You have to practice it. Some things you have to practice something that you may not use that much, or you've never used, or a setting you've never used, or play a song you've never played, to try to really gain your skills, increase your skills. I'm going to do one more thing. I know we've got a couple minutes, and I know we started a couple minutes late. I'm going to go ahead and I'll leave my triggers here, but I want to clear this stuff off the screen. And I want to add a couple things more to it. I'm going to go ahead and change and turn off channel B just to get it out of my way, so we're not looking at it. And I think I want to go back and trigger my channel A. So change my source to A. I want to go negative again. I want to go greater than, and if you recall, it was microseconds. So it's 200 microseconds or so, and that'll trigger that. So now I've got my time-based trigger set. I'm only using channel A, and I just want to add a math channel here, maybe 2 math channels. Again, we're going to use the scope, not just looking at the raw data, but we're going to allow the scope to analyze whatever function we would like. In this case here, whether you're looking at duty cycle and/or if you're looking at a frequency modulated device, frequency would be good. I'm going to go down to my math channels and open up my math channel options. We have a couple that are stock that we include, which is all the inverts, the A plus B, A minus B. We will cover those. We will use A plus B and A minus B on part 3 when we're looking at CAN. In this case here, since we're looking at a pattern that's got a missing tooth, I think I want to look at the positive or negative duty cycle of it. I'm just going to go ahead and select. I'm going to just select both. Let's put them both on the screen. And you may think, okay, what's the purpose of this? Why would I ever use this? Well, looking at a pattern, even if we triggered it properly, and you've got a very intermittent dropout on this crank signal, you've got a very intermittent drop. Maybe it drops, maybe it goes low, maybe it's biased low, maybe it's biased high, and it stays high. And it's not within the normal operating parameters that we have, which is this missing tooth, so many transitions back to another missing tooth. If it's outside that, are you going to be able to catch it? You're certainly not going to catch it by looking at it that's not triggered. So if I would turn the trigger off, and you know that is in free run mode at 5 milliseconds per division or 50 milliseconds per screen, what's the chance, even on a buffer, I've got 64 waveforms in my buffer, what's the chance of you catching that glitch? I don't think it's very good. You can do advanced triggers and maybe set inside and outside ranges for pulse width. Maybe that'll work. I like to use my math channels. I like to graph the frequency or graph the duty cycle, especially at a long amount of time. I can change that from 5 milliseconds. I can go all the way up to a minute and put all that time on the screen. You will obviously have to use the zoom function to go find an anomaly, but the anomaly, if there was one, is going to pop out pretty fast in between these regular events. And you may think, well, what are those doing? Well, the gold one here is negative, so it's running about 50% or so. And when that signal goes low for a large amount of time, that's going to increase to 90%. And it's just the reverse for the positive. So any sort of pulse train, if I'm going to analyze any sort of pulse train, I'm probably not going to just look at the raw data. And I don't think that's always useful. The chance of finding a dropout or a glitch maybe isn't very good. You need to add some tools to that. One of those tools would be using math channels. Another one might be using our advanced triggers. Any of those tools, I believe they have to be practiced in order to be proficient at it when we're not in an environment where we don't have the pressure on us to get this car fixed and get the car out or get it at least diagnosed. We're in an environment when we're learning. I think that's where you take the time and you learn these other options. We're going to add more to that. We're certainly going to add more math channels and do some more CAN testing on part 3, because there's no way I'm going to get to that now. We knew that going into this. That's why we kind of move things around a little bit. But I think at 4 till, I'm going to go ahead and call that. I think that gets a lot of our information that I wanted to get across for this particular event. And I'll open that up then to you, Philip, for any sort of questions that we may have. In fact, I'll just pop in the chat here.
Okay, yes.
Look.
All right, let's see what we have. Well, one question was related to how do you access part 1 to watch.
Okay.
In the registration information, it had the links to go to watch part 1. So revisit that and or shoot us an email and we'll send you a link to do that, or go to shopsquadonline.com to access part 1 and also access part 2 as well.
Correct, and that works well. I've already done that, so.
Mm-hmm.
I'm sorry, I can't see the question, so just as an FYI. So I'm just.
All right, so I'll just keep going. Yeah, no worries. It was a question on tips. They thank you for tips on map duty cycle. And also there was an inquiry about custom probes and creating custom probes
Custom probes, yes, that's something we probably should cover.
in part 3.
Yeah, that can become, now I'll just let everybody know that if you are using a non-Pico accessory, a BNC, but a non-Pico accessory, if you send me the data to it, I will work on a custom probe, but I typically won't do it on Pico time. So it's not going to be done during the day. I'll do it outside of work. There's a lot of forums for that, so I don't do a lot of it anymore. There's so many forums that cover every current clamp and cover every pressure sensor, and there's so many forums that typically has that. I don't have to do a lot of them, but I do them from time to time. And so if you've got one, just have them just contact just via email, via my randy.dillman@picotech.com. I'm happy to help. I'm just, I will need the, I will need the data off of the clamp or whatever you're trying to make a custom probe for.
All right. The next question was related to a new amp clamp, the TA408. It's only the BNC plus.
Correct.
So.
Correct. 408 it's got a very wide jaw. The jaw size is very similar to a TA388. So it's got the jaw size of a high amp clamp, but it's limited to 100 amps. So it's really what I would call, I've kind of labeled it as a parasitic draw type of clamp. Not that it won't work for anything under 100 amps, it's going to work fine, but it's in between everything we've got. It's in between our low amp clamps with a very small jaw versus our TA388, which is a very large jaw, a very, very wide jaw. They're about the same except for the TA388, of course, goes to 2000 amps. I'll be honest with you, I use the TA388 for a lot of parasitic draws because it'll go around any battery cable of any car I'm working on. It'll get me down to an amp really easy, even under an amp, to be technical about it. And then if I have to switch to something lower, this would be the next one. This would be the next logical choice. It's actually something we designed and built for a VM, and we'll release it to the public. So nice premium clamp. It's just got a nice, it's a low amp clamp with a kind of a high amp clamp type of jaw to it.
Another question too, what is your take on utilizing filters? Because sometimes the scope reading could show that there is more hash within a camera crank sensor signal, and it's not really the camera crank, it's the settings in the scope or filtering. What do you suggest on that?
Correct. So if I'm worried about cam and crank, first off, I'm going to be testing it at the PCM or whatever the controlling module is. I won't be testing it out probably outside the engine compartment or in the engine compartment with my leads laying across everything, because I know it's going to create an issue. I want to see what the computer is going to see, and then I always start with unfiltered. I would always start with the raw data, because as I think the question relates to, you can over filter something and make the signal look good, but the signal actually looks bad. And maybe that's the problem, because the routing of the harness that's had an engine install, or it's had head or heads done, and they've not routed the harness correctly. We've seen this with MR sensors. They can get pretty particular about how that harness is being routed. So filtering all of that isn't a great idea. I'm not a big fan of filtering, to be honest with you. I don't filter a lot of my patterns. Maybe a non-reduction or non-gear reduction starter, maybe I'm going to filter when I'm doing relative compression. Otherwise than that, I don't do a lot of filtering. So if that was kind of where that question is going to, I like the raw data myself, and I'll only do it when I think I need to do it, but then I'll also step back and think, why am I filtering this? Why does this have to be filtered so much? Is this normal or not? Maybe that's where the waveform library helps. I think you'll find that most technicians will filter everything. They'll over filter. I find people over filter more than they under filter. They over filter and send me stuff that I can't even I can't even analyze because it's over filtered. Fortunately, if it's DSP, I can just shut it off and look at what we're looking at.
Cool, great. Thank you for, and that looks like that's it for the questions. Oh, actually, one more. When you are looking at Hall effect and with the new style cam and crank sensors, which is magnetoresistive, how do you know the difference? Or does the difference, I would think,
Typically,
questions more along the lines of, is there a big difference in the scope pattern? Because I know from my own testings, I don't see a major difference between the scope patterns between a Hall effect and a magnetoresistive type setup. So
yeah, some MRs can be, the dither or the switch transition is going to be very low. So yes, they can be 0 to 5 and 0 to 10 and 0 to 12. They can also be, 0.5 to 0.8 or very low. So MRs can be very low, and they're not susceptible. They're not always susceptible to rotational speed as well, similar to a Hall effect. But Hall effect, generally your Hall effect is going to be 3 and 4 wires. Your MR can be 2. So I do think it's something that you have to. I think you have to understand when you're looking at the wiring diagram, which is typically where we're going to start anyways, correct? We're going to pull a wiring diagram to see what we're looking at, and where we're going to need to go, and where we're going to gain access to it. I think I do want to know what I'm looking at initially. And we've got guided tests for both Hall effect, of course, and MR sensors. So MR sensors are really become really popular, certainly replace VR sensors that were very susceptible to rotational speed. So,
right.
But not, they were self-excited as well. So.
Great. All right. That looks like pretty much all our questions. I'd like to thank everyone for coming out. Our next webinar is on July 10th at 1 p.m. Eastern Standard Time. Here are the links. More resources can be found at shopsquadonline.com. However, if you want to go directly to for getting support on your testing and related to utilizing your scope, go to support at picotech.com. And NGK Pro Training, if you want to email us directly, you can email us directly at ngkntkprotraining@ngksparkplugs.com. So I look forward to everyone coming back on part 3. And feel free, you have the emails up on the screen. Shoot us an email, any questions, anything you like to see as we continue this on. Thank everyone for coming out. Take care.